Over the years, in a variety of contexts, it's been surprising to me how useful it's been to just take two angles, say A and B, and calculate the cosine of A plus B, or A minus B, or the sine of A plus B, or A minus B. So I want to teach you how to calculate that. Let's start out with just a unit circle, and I'll put the angle A on it and the angle B on it. I'll make A larger than B. And the main ingredient that we're going to use in this potion for making these equations pop out is the distance between 2 points. So let's draw a straight line from the point on the unit circle at cosine A sine A, and then the point cosine B sine B. Straight line through those 2 points, then the distance between those 2 points is the main thing that we'll use. And what I'm going to do now is take this triangle that we have and rotate it so that the point on the right side comes down to the positive x-axis. So I need to rotate it through an angle of B. And then on the left-hand side, what that does is it takes the line that was at the angle of A and it sweeps it up through, it goes backwards through an angle of beta. So it's now at alpha minus beta. So the x value is cosine of alpha minus beta, the y value is sine of alpha minus beta, and now if we take the distance from there down to the point 1 comma 0, that distance is the same as the distance that we had between the other 2 points. There is a nice distance formula when you're talking about 2 points on the xy plane. That distance formula just comes down to the Pythagorean theorem. So I'll go ahead and point out these two right triangles that we're going to use to calculate the distance. And if you look at these right triangles, you can see the heights of the two right triangles. And then for the bases, notice that the x values on the right side of the graph are positive, the x values on the left side are negative. So if you want to calculate the length of the base, take the positive x value minus the negative x value, and that will give you the total length. You'll be adding up the length on the right plus the length on the left. So now, Pythagorean theorem says that the hypotenuse squared, this distance squared, is equal to one side squared plus the other side squared for each of these two triangles, and we can set these two equations equal to each other. They're both equal to the distance squared. And now we can just simplify this. So let's take a look at this left-hand side first. The first term, when you multiply it out, just gives you the first part squared minus 2 times the first part times the second part plus the second part squared. And if you don't believe me, you can just go through the details and work it out. Then we get something very similar for the sine A minus sine B squared. And this looks like a lot of stuff, but it can simplify very quickly. Notice that we've got sine squared A plus cosine squared A, so that's going to be 1. And then the two green terms are also going to just add up to 1. So now we've just got, well, 1 plus 1 is 2, so this is what we've got for the left-hand side. Now we'll do the same thing for the right-hand side. First term, when we simplify it, when we multiply it out, it's just like the last one. First part squared minus 2 times the first part times the second part plus the second part squared. And then that sine squared term, we're just going to leave like it is. And then notice again, we've got a cosine squared plus a sine squared of the same angle. So that gives us a 1. And when we add it to the other one that's already there, this is what we get for the right-hand side. And now the left-hand side is equal to the right-hand side. So to simplify the equation, we can add 2 to both sides. And now we'll just divide everything by negative 2. And that gives us this nice equation for cosine of A minus B. Cosine A cosine B plus sine A sine B. So what if we want to now get cosine of A plus B? We can do that pretty easily. Cosine of A plus B, we can just think of as cosine of A minus negative B. And cosine of A minus negative B, we can just use the the top equation that we already worked out and just plug in negative b into all of the places where there's a b. And now cosine of negative b is the same thing as positive cosine b. But sine of negative b is negative sine b. So cosine of a plus b is cosine a cosine b minus sine a sine b. All right, so now we've got our two cosine equations, the sum formula and the difference formula. Now what about sine? Can we get sine of a plus b and sine of a minus b? Yes, it's not hard. Let's start with sine of a plus b, and then I'll let you do sine of a minus b. So for sine of a plus b, we can relate it to cosine because they're cofunctions. So sine of an angle is cosine of 90 minus that angle. And now you can play around with this a little bit. This is 90 minus a minus b now if you distribute the negative. So I'm going to group the 90 minus a together. And now I've got cosine of one angle minus another angle. So in the top equation that we worked out first, I can just replace all of the a's, or both a's, with 90 minus a. And what's cosine of 90 minus a? That's just sine a. And then sine of 90 minus a is cosine a. So this is our equation for sine of a plus b. You can memorize these equations, but next semester, next year, in 10 years, if you just have practiced this a few times where you just draw the picture and work it out a few times, then it will take you 2 minutes or less to actually come up with these equations in the future. And they do turn out to be useful, just in random places where you wouldn't expect it sometimes, applications where you would not think that these would come up. Sometimes they just do. So it's good to know how to do this. And to get sine of a minus b, what would you do? I'll let you do that, and then you can just Google, or you can just search for the answer on the internet and make sure that you got it correct.